Hello, Sirius Bontia here. I'm a digital mapping graduate student at the University of Kentucky. The mapping project I'm about to discuss was for the capstone requirement for the MAP 673 Programming for Web Mapping course. This project provides an interactive mapping visualization of the Roman territorial expansion from 500 BC all the way up to AD 117. With more than 56% of internet traffic going through mobile devices as of January of last year, 2020, one of my main goals was to tackle the challenge of simultaneously providing mobile-friendly and full desktop experiences through responsive web design. I used traditional map imagery from multiple historic and academic sources to create a comprehensive and updated data set using purely free and open source software. I used QGIS extensively throughout this project, and with QGIS, without a doubt, did much of the heavy lifting in terms of data creation and data processing. I also used Inkscape. I also used the GIMP, not that GIMP, this GIMP, which is the GNU image manipulation program. All coding was done using Visual Studio Code, the free open source version. Last but not least, all programming collaboration with faculty was done via GitHub. Moving now to QGIS. As we can see here, this is the data file that I created. Granted, there were shapefiles that already were available depicting the Roman Empire's boundaries at various time periods. However, these shapefiles did not accurately account for geographical considerations such as mountainous terrain and more recent archaeological data such as roads networks that were more recently discovered. Additionally, these data sets were pretty old, dating back to 2008. Which at the time wasn't bad. However, with better shapefiles and data sets from, for example, the Natural Earth portal, which I'll show you real fast. For example, Natural Earth, they have a lot of newer and neater and more accurate data files. So to use the old data set from 2008 with clean data, accurate data from Natural Earth, you have kind of a sloppy overlap of these layers, which I don't like. All right. So what I set out to do, this became a big project, was to recreate those data sets using Natural Earth as a baseline, but also using geography as a baseline as well, so to more accurately depict certain zones of where the empire's boundaries would be. And again, overall, that was the most challenging aspect of this project, was to recreate that data and also to combine historical information that wasn't always consistent with one another. So I had to try to piecemeal it together and build it accordingly. So if you look on QGIS, in particular the attribute table, this might be a bit hard to see, but essentially what I have here is a table that has a sequence or order 0 through 15. And using that sequencing, I programmed that into JavaScript. So when you go to the website, that data is pulled, and you can see it expand accordingly, right? The slider on the bottom here. So on and so forth. And with that, there's also some visual affordance that's been added. So you can see the highlight as I mouse over certain areas. If you click on an area here, it'll give you more information based on that particular time period, so on and so forth. Moving on further, you scroll out. Here we have a visualization of all time periods, showing the maximum extent of the Roman Empire. Granted, for historical accuracy, these boundaries, especially on the frontiers, would fluctuate over time. but which is difficult to map. However, just for simplicity's sake, I've included all of it together to show like a max extent here. So how does this look with modern map boundaries? Well, we can change the layers here, and this is the National Geographic overlay. You can see where the empire's boundaries have covered quite a significant portion of Europe, as well as Africa and significant portions of the Middle East as well. Furthermore, there is the DARE map out of the University of Gothenburg in Sweden. They have a detailed road network depicted as well. And this is pretty nice. You can see as you zoom in, more detail is afforded, and these map icons correspond with the legend here, all of which is you can toggle as well. So if you wanted to see more, you can do that. Or if you wanted more information on this project, you can hit the book icon on the top right hand side, and it'll provide you more information of this project overall, as well as a more detailed legend, as well as some of the items I mentioned earlier with the data sets. For example, this image here shows the lines from the old data set. As you can tell, these don't really make sense because the way they were drawn, they kind of cover the mountains. Whereas more realistically, you'd expect the Roman Empire's initial expansion to be more something like this, where it goes through the fertile Po Valley instead of just trying to conquer mountainous terrain. So I've updated that data set accordingly. Now it depicts a more accurate model of what it should look like. So again, looking back at QGIS, this attribute table here makes it easy to program for the web with JavaScript. So going on to Visual Studio Code here, this is a quick snippet of what it looks like. If you want to copy it or modify anything that I have here, feel free to do so. It's under a BSD license, so it's free to use. And that's on my GitHub page, so have at it. If you want to make some improvements, go for it. One thing I wanted to point out here too, with that data set that I created, initially was a GeoJSON, which is a geography-focused JSON file, essentially. And it's relatively easy to see what's in the data, right? However, the file size of a GeoJSON can be quite large. In this case, it came out to 1.6 megabytes for the GeoJSON, but if you convert it to a topo.json, this is obviously more difficult to read, but much smaller for the computer to read. It comes down to 265 kilobytes for the topo.json, respectively. So why is that important? Well, the smaller the file size, especially for mobile devices, you end up with quicker load times, and especially when you have bandwidth concerns. If you're using GeoJSONs, it's a really good idea to convert it to topo.json. It's much smaller for your final product, even though it's harder to manipulate on the fly. So save that for the end before you do your final upload and you're ready for prime time. So while we're here in Visual Studio Code, I want to point out the cascading style sheets, or CSS. I have two in particular. One is the styles, which is basically everything that makes the website look the way it does, with images positioned to where they should be. However, one thing to keep in mind is that not everybody uses Google Chrome or Firefox or Safari, and those browsers render a bit differently. So in order to make the slider, which I'll show you here, this slider here look consistent across different browsers, you have to have code that takes that into account. So I have CSS especially for that, to make it look identical between the major browsers. So you got Firefox, Chrome, or Chromium-based browsers, which includes Safari for the Mac users. There's also ways to make it consistent with Internet Explorer. So if you don't do that and you only program for one browser, you run the risk of it looking all cattywampus, and that's not what you want. Okay, so this is the last portion of my presentation. On the left-hand side of the screen, I have Firefox, and on the right-hand side, I have Chromium. And what I want to show here is that this website is responsive, meaning that there's no need to change code or click on any links. The website reacts differently based on the size of the browser, or the size of your screen. So in this case here, you see all the key events and the legends depicted. As I shrink the screen down further, they automatically disappear. If I expand, it automatically comes back. Because if I didn't do that for like a phone, for example, or a smaller tablet, it would clutter the screen. So for a desktop experience, you have the full capability here. And it works the same way with Firefox, like so. And that's the beauty of responsive web design. So that concludes my presentation on this mapping project. It was fun to make, and it was fun to represent the University of Kentucky. They have a great program. Definitely check them out if you're interested in building something similar or something better. They give you a lot of freedom for creativity, and they'll help you out along the way. They got a great staff there. All right, until next time, happy mapping.